They said it would come back from the depths, but it never reappeared. That chilling statement still echoes among the researchers who placed their faith in a 20-foot-long autonomous underwater vehicle. They called it RAN, a marvel of modern engineering, built to explore one of the most hostile environments on Earth, the vast cavity beneath the Dotson ice shelf in West Antarctica. Today, RAN is gone, and with it, a piece of our collective hope to unravel one of the biggest mysteries of our changing planet. What exactly happened beneath those silent, icy waters, and why does it matter so much to the future of us all? In this episode, we are plunging headlong into the story of how an elite international team set out in 2022 to peer under the thick Antarctic ice and emerged with revelations about surprisingly complex melt behaviors, unusual underwater structures, and fresh alarms about climate change. Then, just 2 years later, almost at the moment they were prepared to verify their findings, everything went horrifically off course. Today we will examine the warnings they gleaned, unlock the puzzle of these teardrop-shaped ice formations, and find out why the disappearance of this cutting-edge submersible has left scientists and explorers across the globe both stunned and determined. We will sift through the secrets of the frigid waters beneath the Dotson ice shelf, dig through the unexpected challenges that confronted the crew, and follow the final moments of RAN's last mission. We will also explore what the unique data from this short-lived expedition can still tell us about collapsing ice shelves. By the end of this exploration, you will have a front-row seat to witness nature's raw power, and the stark reality that even our best technology does not always guarantee a triumphant return from the deep. Get ready, because once we begin, there is no turning back. The facts seem simple at first. In 2022, a carefully assembled group of scientists came together under the banner of the International Thwaites Glacier Collaboration. Their purpose: to better understand the rapidly melting ice shelves around West Antarctica. This cluster of floating ice acts as a kind of defensive wall, preventing the large glaciers from sliding off the continent into the ocean. Because these shelves rest on ocean water, it is actually possible to navigate beneath them, albeit with extreme caution. Researchers recognized that the Dotson ice shelf offered a prime laboratory. Though overshadowed in public discussions by the dramatic melt rates of the neighboring Thwaites Glacier, Dotson's underside is riddled with complex thermal currents, fractures, and hidden topography. The objective was clear: a submersible that could endure extraordinary pressures and frigid temperatures, meticulously charting the underside of the ice shelf in unprecedented detail. RAN, a sleek 20-foot autonomous machine, was the answer. Despite its elegant design, the physical hardship of operating under an Antarctic ice shelf remained immense. Scientists had no direct means of contacting it via normal communication or satellite-based GPS. Every mission was a carefully orchestrated dance of sonar pings, pre-programmed routes, and huge leaps of faith. But the potential rewards were too compelling. With new data, the team hoped to explain an intriguing discrepancy. The western portion of Dotson was thinning at an accelerated rate, while the eastern side remained comparatively thicker. Pinpointing the cause could offer invaluable insight into how variations in ocean temperature and current mixing drive uneven glacial melting. Off RAN went, plunging into the ocean's cold darkness. Over 27 days, it covered more than 600 miles, including 10 miles directly inside the enormous cavity beneath the Dotson ice shelf. In place of conventional underwater vistas, RAN captured eerie contours, showing how old fractures had been worn away or reshaped by constant contact with shifting water masses. Among the strangest sights were peculiar teardrop-shaped ice mounds, smooth plateaus, and baffling ridges, all revealed by pulses of advanced multi-beam sonar. These images shattered preconceptions. Where scientists had expected fairly uniform melt patterns, they now saw incredible complexity. The team recorded currents of modified circumpolar deep water, swirling in from the far reaches of the Pacific and Indian Oceans, merging with local waters in aggressive ways. This phenomenon, abbreviated as MCDW, carried not just warmer temperatures, but also disruptive properties that attacked the ice shelf's underside. That interplay seemed to explain why the western edge of Dotson was eroding more swiftly, exposing new crevasses and channels in the ice. Meanwhile, the eastern portion, burdened with thicker ice, appeared more stable. Current climate models, the scientists realized, simply did not reflect the sophistication of these ongoing interactions beneath West Antarctica's ice. For those of us who imagine an underwater expedition to be a serene adventure, the ordeal that the operators faced was anything but. Temperatures beneath the ice shelf hovered at sub-freezing levels, with turbulent flows complicating each new submersible launch. At times, the mission had to be paused as the crew reconfigured RAND's programming to handle unexpected watery mazes. They would hold their collective breath as RAND vanished into the blackness for missions that sometimes stretched beyond a full day. Each completion felt like a small miracle, fueling greater confidence in the sub's capabilities and deeper fascination with the uncharted underbelly of Antarctic ice. But these revelations were not the only dramatic development. As soon as the team published their findings in an academic journal, jaws dropped in the scientific community. The sub had captured an astonishing mosaic of shapes that no one fully understood. One glaciologist exclaimed that examining the underside of the shelf was like seeing the back of the moon, because it had scarcely been observed until now. If you are fascinated by this unraveling of scientific mysteries, consider showing your support by liking this video. It might be just the encouragement we need to continue bringing stories like this to you. While the Dotson mission was technically designed as a test run for the nearby Thwaites Glacier, the significance of the results soared beyond any trial. Each newly discovered detail about underwater fracturing, unusual subsurface channels, or temperature gradients enhanced a sobering conclusion. Antarctica's retreating ice is more varied and unpredictable than previously assumed. For climatologists, these complexities spell a direct impact on projections for future sea level rise. The fact that RAND's data illustrated intricately carved pockets of melting, areas assaulted by swirling water columns, was especially ominous, since it hinted at large sections of ice that might collapse faster than anyone anticipated. And so, in 2024, the team returned to do what scientists do best: repeat the experiment and see how conditions had changed. They intended to set up additional data loggers, gather fresh sonar imagery, and refine forecasting models. Everyone believed that if RAND could successfully map the underside of Dotson once, it could do so again and provide a 2-year snapshot of changes. The sub had proven itself sturdy and reliable, having completed 14 missions in the first expedition. What could possibly go wrong? Then, of course, it did. Not long after the initial plunge of the second expedition, the mood at the remote camp soured. RAND was supposed to surface at a designated time, in a precise location, but it did not. Hours ticked by and the radio remained silent. Attempts to scan for a faint trace of sonar from the sub yielded only static. The unspoken fear: had RAND run headlong into an unexpected ice ridge or snagged in a newly formed channel? Or, as some dared to speculate with a half-smile, was it the victim of overly curious marine life that might have tampered with it? The possibility that seals or other animals had decided to investigate could not be entirely dismissed. Days of frantic searching ensued. Every contingency plan was activated. Expert divers poked around in the chaotic labyrinth near the sea's surface. The explorers scoured all known drop-off points, yet nothing turned up. RAND was gone, seemingly vanished into the shadows it had once illuminated. When the team finally accepted this loss, it was devastating. Not only were they robbed of the data that might have validated or challenged their earlier conclusions, but an invaluable piece of equipment had slipped away within an environment so remote and perilous that any rescue attempt was beyond the realm of possibility. The impact stretched far beyond the immediate circle of oceanographers and glaciologists. With climate indicators growing more dire, the impetus to accurately measure the pace of Antarctic melt was urgent. RAND's findings were already beginning to rewrite scientific models, suggesting that older calculations might underestimate how quickly certain portions of ice shelves can disintegrate. The sub's advanced instrumentation had effectively peeled back a layer of Antarctica's secrets, shining a bright spotlight on a phenomenon that touches every coastal community worldwide. Scientists involved in the project expressed heartbreak for this setback. Many had pinned their professional research goals on the sub's second mission, hoping to gather a new trove of data on the influential role of water currents. Meanwhile, climate experts lamented the loss of an opportunity to refine critical predictions. But the scientists also made it clear that the mission was not a total failure. The bounty of data from the first expedition would still be studied for years to come, offering vital glimpses into the interplay of oceanic forces and ice geometry. Disruptive though it was, RAND's demise might actually magnify public interest in the precariousness of polar exploration. Oddly enough, The story might even serve as a real-world parable about the extremes of scientific ambition. Humankind has advanced to a stage where sophisticated technology can roam beneath Earth's most inhospitable ice, yet we remain subject to the relentless forces of nature. If you appreciate these deep dives into the world's most enigmatic frontiers, consider subscribing to the channel so you never miss another exploration update. Your presence matters, and your support helps us shed light on the hidden edges of our fragile planet. Of course, we cannot ignore the bigger question: what does this unfolding drama under Dotson's ice shelf mean for our future? Rising sea levels pose grave consequences for populations living on every coast. Even relatively small deviations in ocean height can reshape shorelines, intensify storm surges, and force vulnerable communities to relocate. The revelations gleaned by RAN, those teardrop features, the carved-out channels, the swirling presence of modified circumpolar deep water, collectively signal that Antarctica's ice, far from gradually eroding in a predictable manner, is subject to a chaotic process that can accelerate without much warning. This calls for a recalibration of our entire approach to climate strategy, and emphasizes that no tidy, one-size-fits-all model can capture the real hazards. Considering how crucial these insights are, one might expect a certain level of disappointment at the loss of RAN, but the scientific community is nothing if not resilient. Marking one more chapter in the storied history of polar expeditions, the disappearance of the submersible underscores a truth known to explorers for centuries. No journey into the unknown comes without major risks. But risk has always been a companion to remarkable breakthroughs, whether those revolve around discovering new realms on the fringes of the Earth or unmasking hidden dimensions of the cosmic universe. For the men and women who dedicated themselves to this quest, the abrupt end of this submersible's life is a stark reminder that Antarctica is not merely a static land of ice. It is a living tapestry of converging currents, drifting flows, and precarious ice shelves. RAN's mission served as our ephemeral vantage point on that region's otherwise invisible transformations. And in its fleeting existence, it provided an unvarnished portrait of a swirl of watery forces so potent that they can carve labyrinths in the underbelly of a continent, all while defying our neat scientific forecasts. Looking ahead, there is every reason to believe that new submersibles or next-generation AUVs will be deployed. Funding providers worldwide have taken note of the achievements and heartbreak of the Dotson expedition, realizing that if the West Antarctic ice sheet is truly at risk, the cost of ignorance is higher than any sub lost beneath the waves. From the perspective of pure exploration, the lure of venturing beneath the faint light of these entrancing, uncharted caverns is too strong to resist. For the time being, though, RAN rests as an unintentional sacrifice to the swirling waters of West Antarctica. Its journey, documented in troves of data logs and sonar maps, continues to advance our understanding, even if incomplete. Who knows? Perhaps in some future mission, a new craft might detect a faint signal from the original sub, or even stumble upon its remains wedged between ice corridors. That, of course, is speculation. But speculation is what drives explorers to return again and again to the places others have abandoned. And so, we conclude this extraordinary tale of discovery and loss beneath the Dotson ice shelf. In the few short years since the sub's first deployment, we have been granted a striking glimpse of how fragile and how fiercely guarded Antarctica's secrets can be. While the story of RAN did not end the way we might have hoped, perhaps that very outcome will spark a deeper sense of urgency and commitment to protect, study, and respect the hidden corners of our world. We owe it to ourselves, and to every island and coastal city that depends on these frozen frontiers for long-term stability. After all, the drama unfolding at the bottom of the globe reverberates through every ocean current, every coastal community, and every conversation about our planet's delicate future.